The supply of nutrients from the land was ever increasing, as was atmospheric oxygen. The amount of ferrous iron in the oceans increased. The ferrous iron oxidized, once again creating large bands of iron. Phosphorus and calcium levels in the ocean increased. Life evolved to use these elements, becoming animals with bones and shells. For example, the calcium helped protect Microdictyon from other animals. Their bodies used calcium to form a covering of hard scales. Life evolves to survive, making use of the elements in its environment. And the Earth's environment alters the shapes of life. The Earth entered another period of climactic instability. The Earth alternated between periods of extreme heat and extreme cold for tens of millions of years. These severe changes killed off the Ediacaran fauna. Nevertheless, new species were about to appear. Radiation from inside the Earth plays a significant role in the evolution of life. A continental rift is a place where a continent breaks open to expose erupting magma and radioactive elements. Radiation hastens the creation of new species and new branches in the tree of life. This is stem evolution, creating new species at continental rifts. Life evolved separately on each small continent. When small continents recombined, their life forms crossbred. Different crossbreedings created new forms of life. Variation thrived. This is crown evolution. Continental collisions created more diverse surface environments. Bays and gulfs on large continents were especially well supplied with nutrients from upstream. Making use of these nutrients, Cambrian-era life forms diversified much more quickly. The Cambrian explosion created some 35 new phyla. These phyla became the foundation for the types of plants and animals we see today. There are three main ways that life evolved. Mass extinctions that eradicated many species. Stem evolution that hastened genetic mutations when continents broke apart. And crown evolution that hastened biodiversification when continents collided. So, the evolution of life is inextricably linked to environmental changes due to universal factors and continents assembling together and breaking apart. The ocean was more than 5 times as saline as it is today. 600 million years ago, the ocean gradually became less salty. Salt from seawater was relocated to the land in the form of rock salt. Decreasing sea levels made this possible through more exposed land. Even if seawater rose again high enough to reclaim the rock salt, most of it had become inaccessible, encased in sediments. The decrease in seawater salinity made the ocean more hospitable to diverse life forms. Estuaries and open seas welcomed new life. With increasing atmospheric oxygen levels, an ozone layer formed in the Earth's upper atmosphere. The ozone layer absorbs ultraviolet radiation from the sun. The land was becoming a more habitable environment. Algae was the first life form to transition out of the water onto the challenging land environment. This is why algae evolved before animals did. When insects appeared, they co-evolved together with plants. Appearing during the Cambrian explosion, fish were the first of the vertebrates, animals with backbones. Fish are the oldest vertebrate ancestors of us humans. As fish continued to evolve, Ichthyostega appeared, the ancestor of amphibians. Plants flourished, producing free oxygen through photosynthesis, providing the atmosphere with 1.5 times as much oxygen as it has today. Long after, the remains of these plants would become sedimentary coal. That coal would help fuel the remarkable breakthroughs for human civilization that started with the Industrial Revolution. Next, vertebrates equipped with lungs appeared and made their way onto land. The tree of life evolved, branching from fish to amphibians to reptiles and then dinosaurs and mammals, and eventually to humans. This guy hasn't found out about all that just yet. The solar system collided with a dark nebula. As the solar system passed through the nebula, the Earth was bombarded with cosmic rays. The Earth entered yet another frozen age. Plants were affected first, dramatically reducing the oxygen they supplied to the atmosphere. The surface environment reverted to an anaerobic state, like during the Archean period. The lack of oxygen killed off most species of amphibians, reptiles, and insects. Life managed to continue evolving, but faced another big challenge. Untouched by the evolutionary changes on the Earth's surface, anaerobic microorganisms had been thriving in oxygen-poor underground environments. The new oxygen-poor surface environment allowed them to re-emerge on land and in oceans. Their native habitat expanded across the globe. As oxygen levels rose again, these microorganisms evolved to adapt to the new environmental conditions, setting the stage for another phase of evolution. The emergence of new creatures that would evolve into humans was close at hand. On the supercontinent Pangaea, mammals and reptiles appeared and started evolving under a warm climate. While reptiles diversified into many varieties, mammals remained nocturnal, rat-sized animals. The mammals were in the shadows. With the appearance of dinosaurs, reptiles entered a golden age. Dinosaurs prevailed against many other animal species and won the struggle for survival. High radiation magma is produced when a continent is split apart, and this is where stem evolution occurs due to induced mutation. Dinosaurs were at the pinnacle of their ecosystems. The pieces of northern Pangaea that had split later rejoined. This caused crown evolution. Amalgamation of continents brings the hybridization of life, and new species spread out to other continents. Dinosaurs flourished all over the world. In the plant world, angiosperms with advanced reproductive capacities appeared. Angiosperms utilize animals to help with pollination and thus flourished. On the other hand, the habitat of gymnosperms was reduced. Primates, the ancestors of humans, appeared at the rift of the Gondwana supercontinent. Via stem evolution, new species appeared among the rodents, such as rats. With time, Gondwana split into South America and Africa. After South America was isolated, the primates there evolved into the New World monkeys. On the African continent, the primates evolved into the Old World monkeys. After the Indian subcontinent split off from Antarctica, primates on this continent evolved into the lorises. Primates evolved independently on each continent. And in this way, many species of primate appeared. A large-scale Pacific superplume pushed the Pacific plate up and raised the sea level. Lowlands fell below sea level, and the total land area decreased. Rising sea levels segmented the continent, providing isolated environments for individualized morphological evolution. A universe-scale event had changed Earth's surface environment. The solar system collided with a dark nebula. The Earth was entirely covered by clouds. Global cooling progressed, catastrophically damaging ecosystems. Finally, a meteorite 10 kilometers across fell on the Yucatan Peninsula. This event was the final trigger to cause the mass extinction of dinosaurs. The fate of the Earth's life is deeply connected to the events in the universe. Universe-scale events can cause global cooling and mass extinctions. Moreover, galactic cosmic rays directly affect the DNA that carries the blueprints of life. Cosmic rays cause mutations which promote evolution. All aspects of life on the Earth are thus influenced by universe-scale events. Finally, the dinosaurs that had flourished went extinct. Along the African Rift Valley, explosive volcanic activity continued, and peculiar magma containing abundant radioactive elements erupted. Old World monkeys, a new clade of primates, appeared there. They are thought to be our remote ancestors. About 4.5 billion years have passed since the birth of the Earth. Large fluctuations in terrestrial environments have occurred repeatedly, a never-ending cycle of life and death. Finally, human beings appeared. This was the onset of the Humanozoic Eon. Humans have a unique set of genetic regions called human accelerated regions, or HARs, and these regions differentiate humans from other animals. Humans developed enlarged brains that enabled them to gain language capabilities. They also gained the abilities to think, to be conscious, to remember, and to imagine. The brain volume of human beings has discontinuously increased in 3 stages. The growth of brain volume seems to be synchronized with large-scale volcanic eruptions. This indicates that the increase in brain volume is caused by stem evolution, driven by high R magma. About 1,200,000 years ago, humans started moving out of the African continent. The last common female ancestor who left the African continent 200,000 years ago is called mitochondrial Eve. Descendants of mitochondrial Eve entered North America and Central America 15,000 years ago. 10,000 years ago, further descendants reached the southern tip of South America. They had spread all over the world. Since then, an epochal advance of human civilization has taken place. Humans invented agriculture and livestock production. With these methods, a stable food supply became possible. Human populations increased rapidly. Various occupational specializations arose. People began to barter and trade. To enable effective bartering, cities formed. With time, small cities developed into small city-states, with currencies, economies, laws, courts, and police. Finally, the four great civilizations of the world appeared along large rivers, where food productivity is higher than in other regions. Conflicts and fighting over territory occurred between civilizations. To avoid fighting, religions spread to replace governance by royal families entrenched through inheritance. With time, national leaders came to be elected by voters. Modern democratic nations appeared. Democracy is a social form that grants freedom, equality, and basic human rights. The Industrial Revolution began in Great Britain after the Principia by Isaac Newton was published. New technologies, established or applied based on scientific knowledge, dramatically changed human society. The invention of the steam locomotive enabled transportation of goods by railway. The invention of cars and airplanes enabled us to travel long distances easily. Human society entered the age of never-before-seen abundance. However, war occurred incessantly. Sometimes, irreversible tragedy was caused by the misapplication of scientific knowledge. The information revolution arose following the invention of computers. It enabled human beings to explore the universe, as was symbolized by the Apollo program. And the invention of the internet led to a new era in which people across the world can connect with each other in an instant. Out of contrition over past wars, the birth of a unified world nation is coming to be realized. In 1993, the EU was formed as a unified state in Europe, where wars had recurred most frequently. In other areas, similar federations have been emerging, bringing us closer to the birth of a unified world nation. Within the scope of Earth's history, the Humanozoic era is very short. However, it is humans' entire history, unfolding within the context of the Earth's history. Biologically, human beings are just one species of animal. However, we are essentially different from other animals because of our evolved brains. What else lies ahead for human beings? Human activities have been dependent on fossil fuel. Fossil fuel was produced and accumulated through Earth's history over billions of years. We are now using up these fuels at a furious pace. The amount of fossil fuel remaining is expected to decrease sharply after 2020. It was once assumed that fossil fuel would run out by 2100. However, due to the shale gas revolution, this depletion will be delayed 100 years. Progress in medical technology and the intake of nutritious meals has caused explosive population growth. As a result, serious food shortages will occur around 2020. These will mark the beginning of the era of 3 billion refugees. However, the world's population is expected to decrease to 5 billion by 2100, after peaking at 10 billion in 2050. Until 2050, the increasing population will continue to cause serious environmental contamination. Numerous global challenges will amplify the anxiety within human societies. What does the future of human beings hold? In the field of science, innovative technologies will be developed at an accelerated pace. Humans will build a space base on the Moon to prepare for exploration of our solar system's planets. Artificially intelligent robots will be involved in space exploration, assisting humans in their tasks. In the near future, self-replicating robots will appear and will evolve beyond humans' limits. These artificial life forms will gradually travel out into the galaxy. Moreover, new technology enabling us to go into different dimensions will be developed. Humans must become able to recognize the world beyond space and time. Eventually, the role of human beings will be finished. That will be the end of the Humanozoic era. This scenario may be the inevitable result of the strategy of life's evolution. Because in the future, the Earth will face more upheavals than ever before in its history. Centering on Asia, all continents will gather to form the supercontinent Eurasia. Plants consume atmospheric CO2 to fix carbon in their bodies. Dead plants made of fixed carbon are covered by sediment. This process plays a role in reducing atmospheric CO2. The appearance of the supercontinent Eurasia will lead to an increase in the land area that can fix carbon. More plants on a larger supercontinent reduce more atmospheric CO2. The amount of CO2 will decrease to 1/10 of the present level. The C4 plants, requiring higher concentrations of CO2, will go extinct. As a result, other animals that rely on the C4 plants for food will be affected. Seawater has been decreasing for the past 600 million years as it has been transported into the mantle in the form of hydrous minerals. Finally, mid-oceanic ridges form summits above the seawater. Water cannot be taken into the crust as a lubricant anymore, and plate tectonics is terminated. This is the fate of a cooling planet. Volcanic activity along the subduction zone stops. Upheaval of the mountains stops. The Earth suffers severe environmental changes due to erosion. Subducted cold plates do not go down to the bottom of the mantle. The outer core is not cooled down anymore, and the geomagnetic field disappears. Earth's atmosphere is removed by the solar wind. At this point in time, large multicellular animals living in the surface environment go extinct. When the ocean disappears, animals that survived in the ocean will also die. Finally, all the Earth's life disappears. The heating up of the solar surface increases the Earth's surface temperature to 500 degrees Celsius. The Earth becomes a Venus-like planet. The Andromeda Galaxy collides with our Milky Way galaxy. Because of this collision, the birth rate of stars increases. With time, those stars undergo supernova explosions. Intense galactic cosmic rays rain on the Earth. The expanding sun will swallow the Earth. This is the day when the planet Earth, that gave birth to life, will disappear from the universe. By that time, the Earth's life will have reached other galaxies as self-replicating artificial life in a different form.